All right, welcome to Developer Roadmaps. Today, we're going to talk about something you use every single second you're on a computer, but probably don't think about much. It's the invisible engine that makes everything work, the operating system. Seriously, just stop and think about that for a second. What if, to open a file, you couldn't just double-click? What if you had to write a little piece of code to do it? Every single time? Sounds like a nightmare, right? So, here's what we've got on deck. We'll start with that world without an OS, then meet our hero, the great intermediary. We'll dig into its 4 core jobs, check out a real-world powerhouse with Linux, and then, of course, put it all on your developer roadmap. All right, let's dive into Section 1, a world without an OS. Yeah, it's about to get chaotic, but this is the best way to see why these things are so unbelievably important. Okay, so let's say you just want to write a document. Without an OS, you'd have to personally, manually tell the hardware, hey, load this word processor program into memory. Then, for every letter you type, you'd be telling the monitor exactly which pixels to light up. And when you want to save, you guessed it, more manual commands to the hard drive. Exhausting. You know, NISO Academy puts it perfectly. For every tiny little task, you'd have to explicitly tell the hardware what to do, with code. It's not just tedious, it's a massive barrier. Computers would be tools for only a tiny handful of experts, not for, well, for everyone. So out of that chaos comes the solution. The OS is our great intermediary. Think of it as the ultimate master translator that steps in and handles all that complexity for us. But what is an OS really? At its heart, it's just a really important program. Its whole job is to act as a go-between, connecting you and your apps to the physical computer hardware. It manages everything, so your programs can just run. They don't need to know the messy details, and that's the whole point. It's all about convenience and efficiency. This diagram really lays it all out. You're up here at the top, using your apps like a browser or a code editor. Now those apps, they don't talk directly to the physical hardware down at the bottom, no way. They talk to the layer in the middle, the operating system. And the absolute core of the OS, the kernel, is what takes their requests and translates them into a language the CPU, memory, and all that other hardware can understand. Okay, so how does it actually do all this managing? What's the secret sauce? Well, it really boils down to 4 main jobs that the OS is constantly juggling behind the scenes. We're talking about process management, memory management, device management, and file management. The best way to think about it is that the OS is the ultimate project manager for your computer. Its entire goal is to make sure every single resource is being used in the best way possible. First up, process management. I mean, think about your computer right now. You've probably got a browser with a dozen tabs, maybe Spotify running, your code editor. So who gets to use the CPU? All of them? The OS plays traffic cop. It switches the CPU's focus between all these running programs, these processes, so fast that it feels like they're all running at the same time. That's the magic of multitasking. All right, number 2, memory management. This is a big one. The OS gives every single program its own little sandboxed area in your computer's RAM. That's super important because it means your web browser can't just reach over and mess with your code editor's memory and crash it. And when you close an app, the OS swoops in and reclaims that memory so something else can use it. For us as developers, this is huge. If your code handles memory poorly, you're looking at slow performance and, yeah, lots of crashes. Then we have something we completely take for granted every single day: file management. You know, your hard drive or SSD, at a basic level, it's just a giant, messy pile of ones and zeros. It's the OS that brings order to that chaos, organizing it all into the neat files and folders that we actually understand and can work with. And last but not least, device management. I mean, how does Microsoft Word know how to talk to the thousands of different printers out there? The truth is, it doesn't. It can't possibly. Instead, your app just tells the OS, hey, I want to print this. The OS then looks up the right translator, a little piece of software called a device driver, and uses it to give your specific printer the instructions it needs. It's a universal translator for all your hardware. Okay, that's the theory. But to see how impactful a great OS can be, we need to look at a real-world example. And there's no better example than the absolute powerhouse that is Linux. So where did Linux come from? Well, it has roots going way back to the legendary Unix operating system from the late 60s.
Then, in the 80s, an educational OS called Minix came along, and in 1991, a college student in Finland named Linus Torvalds, inspired by both, decided to build his own kernel, and he released it to the world.
Now, here's a really important thing to get right. When we say Linux, we're usually talking about a whole family of operating systems. The Linux part is actually just the kernel, the core engine, like the engine in a car. Then you have different distributions or distros. Think Ubuntu, Fedora, even Android, which are like different models of cars, all built around that same powerful Linux engine. And the scale of its success is just mind-blowing. Let's look at the numbers. 100% of the world's top 500 supercomputers run Linux. Over 96% of the top 1 million web servers? Yep, Linux. And your phone? If it's an Android, you're running a Linux kernel. This is why it's so critical for developers, the cloud, servers, embedded devices. It is literally the invisible backbone of the modern internet. So, the big question, why should you, as a developer, care about any of this? This is where we bring it all together and figure out where this fits on your roadmap. Okay, now let's place it on our roadmap. This is a fundamental checkpoint on your developer journey. Seriously, understanding the OS isn't just some boring academic exercise. It is the literal foundation that every single line of code you ever write will stand on. So let's wrap this up. What are the big takeaways? 1. The OS hides all the messy hardware details from you. 2. It is the ultimate resource manager for the CPU, memory, everything. 3. It's what makes multitasking and security even possible. And most importantly for you, understanding this stuff is what separates a good developer from a great one. It helps you write faster, more efficient code. This is non-negotiable, core knowledge. We've peeled back the layers and looked at the very foundation of modern computing. So now the question I have for you is, what amazing things are you going to build on top of it? This is Developer Roadmaps. Map your path. Build your career.